Hi there, it's David Williams again from Okanagan College, and talking some more about electromagnetism. And in particular today, what I want to talk about is Faraday's law, which is named after Michael Faraday, one of the earlier experimenters in electricity and magnetism. And we have a picture of him here. And it was for Michael Faraday that the farad was named, the unit of capacitance. And it took me a long time to figure out where the Farad was named, or who it was named after, and it was only a couple of years ago actually that I figured that out. Now, I'm not going to tell you what Faraday's law is yet. I'm going to show you a couple of animated experiments. Now, this is from the PhET webpage, and you can find all sorts of great physics animations and science animations on the PhET webpage. And this one in particular is demonstrating Faraday's laws, and this one's called Faraday's Electromagnetic Lab. Let's see if I got that site here. I do actually. So I'll bring that down. Here's the website for Faraday's Law Lab, Faraday's Electromagnetic Lab. So you can take that website down and check it out yourself and play around with it. It's kind of interesting to play with it and see what kind of different effects you can get. Anyway, let's go back to the actual lab itself. So what we've got here is a permanent magnet with north and south, and we can see the magnetic field that's created from that magnet around in the screen here. And inside the magnet we've got a loop of wire to which a light bulb is attached. Now, here is a demonstration of Faraday's law. And what you'll notice is I move the magnet and the light turns on. And in particular, when I move the magnet, notice what's happening with the magnetic field. It's changing. So Faraday's law says that if you have a changing magnetic field, that is going to induce a voltage. In this case, we've got a completed circuit, so it's going to induce a current in the circuit, and that light bulb is going to turn on. Here's something else that's kind of interesting. Okay, I've got 3 loops currently, and it's off the screen, but I can change the number of loops. I can change it to 2. Change it to 1, and look at the light bulb as I change it. So I'm going to change it now, and you'll notice that the light bulb turns on as I change the number of loops that we have. And also, if I change the area, you'll notice the light bulb turns on just very briefly, very dimly, as I change the area that the magnetic field, or the area that the magnetic field passes through. So the basic fundamental underlying equation for Faraday's law is this. If you have a changing magnetic field, that is going to induce a voltage. And in particular, it's a changing flux with respect to time. So the induced voltage is going to be equal to the rate of change of the flux with respect to time times how many loops you have. Another way to write this is if we remember what flux is, and we actually write flux in terms of flux density. So flux is going to be equal to flux density times area. So N times flux density times area is equal to flux. So you can see from this equation here is if you have a changing magnetic field, you'll induce a voltage, or if you have a changing area, you'll induce a voltage, or if you have both. So you can go back to the Faraday's law and see here's the changing magnetic field induces a voltage which creates a current, or I'm going to shift this over a little bit. Maybe I can change the loop area. And the changing loop area, it doesn't change it quite as much because the magnitude of the change isn't so huge. But you can see if I'm changing it quickly enough that the light bulb does light up very briefly. Now this has all sorts of useful applications. And the most useful application is going to be in a generator. We got a little cartoon of a generator here. We turn on the tap. This magnet's going to spin. It's going to create a changing magnetic field. That changing magnetic field is going to turn that light bulb on. That's all that an AC generator is. And you can see that if I change the area, or even if I change N, I guess you can't see it light up so much. Oh, there we go. Decreasing it doesn't light up so much. Increasing it, it does. If I change the loop area from 100%, let's slide this over a little bit more, 100% down to 92, oh, there we go. Let's slide it back and forth, and now you can see I'm changing the area, so I'm going back to the equation here, the dA dt, the area is changing with respect to time. I'm going to reduce the voltage, which in this example is going to create a current. And that is Faraday's law.